How are you doing today?
I'm good. I'm good. Thank you, Laurence. Thank you for having us today, and thank you for the introduction.
Lovely stuff. I'll pass over to you, Chris. You've got an exciting presentation lined up. So,
Thank you, Laurence. So, innovation in media using the cloud. So, Laurence asked us to talk about this subject, and something I've spent a couple of years, the last couple of years, working with the media industry on an innovative deployment fabric, shall we call it. So I'll give you a little bit of a journey on how we got there. So this all started with the IBC Accelerator Program. So IBC is the International Broadcast Convention trade show, happens every year in September in Amsterdam. We, as a consequence of the work we've been doing with IBC the last 2 years, we're sponsoring the accelerators this year. And it's this media innovation program where they get together broadcasters, they call them champions, to solve common problems across the media industry. So this year we're working with everyone from BBC, ITV Channel 4, EBU is the European Broadcast Union, who are quite involved in this deployment fabric that we're going to talk about. We got, it really international this year. Comcast, United States, of course, Globo, Grupo Globo, that's the main broadcaster in Brazil, Wiley in Finland, and Rai in Italy. So the Media Innovation Program, the broadcasters get together to solve problems. And this year we're doing anything from AI-assisted agents to master control room in the cloud to low latency streaming at scale. But I'll take you back to 2023 when we started on this journey for this deployment fabric. And the premise was, well, the champions are there at the bottom. It was BBC, BT Sport, as they were then, DAZN, who are currently broadcasting the FIFA Club World Cup live. It's just started that competition. Sky Sports, a big innovator in live sports events and productions, and of course WBD, Warner Brothers Discovery, our friends here on the online conference with us today. They were in the form of Eurosport. Part of Warner Brothers Discovery. So the premise was that in a bandwidth constraint, so during COVID, production had moved to the cloud. So everyone's like, we've kind of sort of knee-jerk reaction. People couldn't go out. They had to do their live television production in the cloud. But in a bandwidth constrained environment, that may not be possible. But the broadcasters liked what they found in the cloud, and they said, well, we like a cloud-like deployment, but we want it anywhere. So thus was born the project Connect and Produce Anywhere, and it was commonly known as CAPA, C-A-P-A, Connect and Produce Anywhere. So Google joined the Connect and Produce Anywhere project in 2023 and 2024 with the champions that I've just mentioned. And where did we fit in as Google? So we brought what we call Google Distributed Cloud. It's like a cloud deployment fabric for video production. We brought it to the edge, to the broadcast truck, or similarly in the cloud. So, deployment in the cloud is well known. People move to the cloud for different reasons. So that people will go for the simplicity, the speed, the security, the scalability, all the good reasons that we love the cloud. Excellent for burst, excellent for access to so many, very mature services, and my fellow speakers today will give you a rundown of some of those reasons to move to the cloud and how to move to the cloud. But as I mentioned, not all workloads are always perfectly suited to the public cloud. And the one I'm going to comment on here is this survivability, when processing needs to continue even if the connection is down. So live sports event, you've got your producer, your vision mixer, your audio desk, your commentary, everything all happening. You don't necessarily want to run that in the cloud because you're absolutely reliant on all your upstream. That's the other thing. 10 cameras, 15 cameras, high mezzanine bitrate, up it goes to the cloud. And it's a lot of upstream bandwidth. So bandwidth constrained environments was one of them. Latency and speed, when speed is everything. So subtitling, real-time inference with AI, and just synchronization. Cut if you're shooting a racing car series, F1 or Formula E electric racing car series. Car comes around the corner, you cut to camera 2. Car's gone. When 50 milliseconds makes a lot of difference. So latency is a big factor. Local data processing and data sovereignty in regulated industries is another use for Google Distributed Cloud. So what we've done at Google as I mentioned, we love the cloud. We love you to deploy to the cloud, broad scale and fast solution development. But now we also have Google Distributed Cloud. So it's extends Google Cloud infrastructure and the services that you know and you love to either to your own data center or to the edge or to the outside broadcast, or commonly known as the OB truck, or the sports venue. So back to our project with IBC, what we got together. So it wasn't just Google on this. We had VizRT with Zixi were on there, TechX were on there. So members of the broadcast vendor community, and we set out to run what you see in this blue box. It says here edge compute. That was how we defined it. Vision mixing and stream transport, and Llama, lean and mean audio, Dutch audio mixing desk software. We wanted to run all of that, I say in Google Cloud, in Google Distributed Cloud, so running it at the event. So what did we do? I got some servers, because when it's not in the cloud, you get back to the servers. I went and picked them up. Got them in boxes. To be fair, it was the first time I touched a physical server in a decade or so. Lots of experience with servers, but not so much recently. So in they go to the rack at our partner TechX. Small cluster, very simple, nothing fancy. GPU card, NVIDIA GPU card. More on that later and why that's important. So pretty standard. And then, of course, we did the software install for Google Distributed Cloud, which is it's a Kubernetes environment with extensions. So it has VM runtime, it has Istio management, and GPU support, machine VM shape support, and of course all the great Kubernetes stuff. And then you can manage it as a Kubernetes cluster as if it were in the cloud alongside your existing cloud Kubernetes clusters. And then you have something called fleet management. So the goal was back in 2024. It seems so long ago. It's only a year ago, just over a year ago. Get that cluster on site at the kickstart day for the next year's IBC accelerators. So back in the boxes, off we went to the IET. Incidentally, it's on the Strand in London, the location of the first radio broadcast in the UK. And Faraday was once a chair of the IET back then. So historic building. So we took them out of the boxes and then put them in flight cases, so it didn't look like we just had some servers lying around on the floor. We connected everything up. This is my colleague Jorge. He's also a Google Cloud engineer. We've got the cluster set up. So it was basically this, right? On the video production side, all IP video production. So, well, from SDI to NDI bridge, kindly provided by VizRT. A few cameras. This is essentially a controller, all just going into a 10 gig switch. Into the 10 gig switch goes your Google Distributed Cloud cluster, as it's known. We were using AMD processors, VizVector Plus, TechX for transport, Zixi was all installed on there. Quite a small cluster, but we ran everything on there, and that was the goal of the Media Innovation Project. So we got it up and running. It was pretty close. Lots of partners and sponsors, room full of people. This is Ian Wagner from the BBC R&D at the time. He's presenting on stage. Now, you can't see it here, but maybe you can see it a little bit on Liam's screens here, where he's got the Viz software running, and he's doing the mix, cut between the cameras. You can just see a camera just over there in the back of the room, just there. And of course, when Ian's speaking on the stage, and I know you don't see him projected on the big screens here because they've cut to slides, but it's important that you get the synchronization between what's going on the screen and what's happening in the presentation. Anything more than about 5 frames, 200 milliseconds, it looks out of sync, and lip sync goes out as well. If you look at the screen and you hear the mic coming over, they're not in sync. So that's a low latency requirement for live production when you're presenting back to the screen. And I'll get on we use NVIDIA GPUs for the vision mixing, but there's another thing that NVIDIA is popular for, which I'm sure we're well aware of, and that is machine learning training and inference. So if you need to do real-time, low latency speech to text and then subtitling to keep that in sync with what's going on at the event, excellent application of distributed cloud close to your event. So a few pictures of us, slightly panicky. We've got this. And then we go on to Formula E. So a little bit after our kind of first outing, it was like, okay, great. So this is a customer of ours that we work, we've migrated plenty of their workloads to the cloud, not all of it. Some of it runs at the track, we call it trackside. And they have some containerized workloads trackside. And then they also use some network for remote production as well. So I've got some pictures of the cars because they're nice, Formula E electric racing car series. And then we've got the, I went and I took all these pictures of the cameras. So cameras up on cranes, cameras on the pit lane, cameras on the car, cameras in the stand. There's about 10 cameras on the car, actually. There they go. There's one in the back, got them in the wing mirrors, and they've got this telemetry on the side of the car. So there's a lot of high-tech stuff in these cars. And, oh, yeah, there we go. There's a camera on his shoulder interviewing the guy in the chase car. And that all goes back to the media compound, where you can see these things fit in an airplane because they've got to move this stuff around. And there's basically a bunch of software running here, right? And this bottom right hand, that's the gallery, which is running software, which is running either on these, typically provision boxes, but you can see there's some commodity hardware in there anyway. So that is during the race and the mix. So that was really just our call that like a field trip to the races. So, Formula E being a customer of ours and IBC being a partner of ours for this innovation project, we said, hey, can we bring down our media deployment fabric to Formula E for the race weekend in London? So 19th, 20th, and 21st. It wasn't in 1921. That'd be a long time ago. 19th, 20th, and 21st of July last year, Formula E London season finale. Same thing happening this year in July. And they said, yeah, sure, we'll give you a porta cabin, some AC, we'll give you 50 camera feeds. Yeah, we'd love to see it. We're really interested. So out came the cluster. I might have forgotten to show you the cluster, but there we go. It's got a new flight case, same 10 gig switch, same team. This is again Ian Wagden from BBC. That's the guy from Channel 4 at the end, and Lean and Mean Audio. They're mixing the sound, and this is a controller running the software on the Google Distributed Cloud Cluster. And we took the camera feeds from the race, and we did a bunch of mixing. So the accelerators, there we go. This is our stand when we went off to IBC in September, and we were kind of playing back some of the footage, and we had a panel, and the partners are all up there. So real innovation motivated by IBC, and then bringing together what we call participants, that's Google and Zixi and TechX, and then champions, that's BBC, DAZN, Warner Bros. Discovery, Channel 4, etc. So bringing it back now down to the product, and this has really kind of evolved into a trend in the industry for live, not just for live production, but for all sorts of media workloads, as commodity hardware has become capable of running high capacity mission critical video workloads, particularly with the use of the GPU. Then you don't need an ASIC or an FPGA in your kind of custom piece of hardware to do your vision mixing. You can run out on a GPU in a server or in the cloud, and then having that deployment fabric across the two has been a really, really powerful concept. There is a lot of activity in the industry looking at this. And then we have this thing, so we have GDC on the left and GCP, Google Cloud Platform, on the right. And then, for example, because you have availability of NVIDIA GPUs, you can run your AI model locally for your low latency inference requirements. Yeah, you can train your model in the cloud should you need to, and use the whole Vertex AI platform. Same thing, you can run your local containers here, but you can use container repository in GKE in the cloud, and you can either burst to the cloud or your steady state workload in the cloud as well. Same thing, you've got your GDC cluster and your Google Cloud Platform GKE fleet, and they can be interconnect, cloud VPN, internet. We even have a version of Google Distributed Cloud we call air-gapped. So, all the different flavors you could possibly mean. It's getting a lot of traction in the industry. You'll see a couple of the slides coming up in a minute. In fact, Jensen was on stage or on video announcing at Google Cloud Next just a few weeks ago, and that is the H and the B400 GPU support, which more on that coming up. How am I doing for time? So you get all the benefits of cloud, identity access management, you get send all your logs and your operations and your monitoring and your incident management to the cloud. All those things that you don't need to be running on-prem and are well taken care of in the cloud, do that there. And then you can run your the parts that you need locally. This is actually not Jensen. This is our VP of infrastructure, and this isn't even this year's Next. This is last year's Next when we first started talking about NVIDIA GPUs to Google Distributed Cloud. These are quite interesting industry trends. Now, to be fair, they are motivated largely by AI, but media industry is the beneficiary of this, because you can run your media workloads on that same NVIDIA Google Distributed Cloud infrastructure stack. So deploying live production media workloads with GDC. This is a bit about you can get to use the specialized hardware, so specifically the NVIDIA GPUs. And you get the best. Like Google has got a long history of Kubernetes, not least having kind of written it and given it to the community, but containerized workloads, and we're bringing that, so we're not just running it in the cloud or contributing to an open source project. We're bringing that service platform to our own distributed cloud. And then there's this, you've got access to the whole pre-trained model ecosystem. So more you'll see in a moment about running AI models on your distributed cloud as well as in the Google Cloud. I'm going to skip over that one. Specialized hardware. So this is what I was mentioning. This is what Jensen from NVIDIA was talking about. The H100s and the L4s and the T4s. These are the video GPUs, but the H100 GPUs. These, because they run Google's large language models, so not just your fast detection and your kind of low latency inference models, but your large language models such as Gemini Flash and Gemini Pro, up to versions 2 at the moment. We are now making those available on Google Distributed Cloud, and that's why the H100 GPU support has come in. So high bandwidth networking between the machines, so you can have a model that's split over more than one GPU. They've got decent Intel processors in them, and then the storage component. There's all access to Vertex AI. Vertex AI is the name of the Google Cloud Platform for your MLOps, your your AI pipelines, your model training, model garden, access to all of those things. And you can then deploy Vertex AI search on Google Distributed Cloud. So for certain regulated industries, for example, where you might not want to index all of your data in the cloud, you can index it locally. Model Garden, as I mentioned, Gemma is Google Cloud's open source, or I should say open weights model, and pre-trained models, speech to text translation, these low latency requirements, RAG-enabled search solution on GDC, that was the Vertex AI search. And so this was really where it culminates, is Gemini on Google Distributed Cloud. So we were running these media workloads, but what was really exciting was that, I thought, well, AI can influence everything in the production control room, to hinting, to camera switching, to translation, to subtitling, to speech to text, to real-time translation into a different voice, all of those things. And now with Gemini as well, so large language model. Of course, Gemini with its long context window, different versions, we have Pro, Flash, Flash Lite, all being available on Google Distributed Cloud. And then, just a little bit on that. This is the most recent announcement from Google Next. We have this, as I mentioned, connected. Customer can supply the hardware, or Google can supply the hardware, or we have air-gapped, so you don't even need to be connected to the internet. And then this is all the good stuff that I've been talking about so far. All of the infrastructure, all of the common GKE services and the networking and all that good stuff. And now on top we have Gemini, Gemma, and open source or open models from our Vertex AI model garden. And I think with that, I actually forgot to put my closing slide in, but yeah, that's the end of the presentation. It's just a little journey that we've been on with IBC, with the broadcasters, and it's really come to fruition with Gemini on Google Distributed Cloud, and the NVIDIA being a key piece of that. So thanks, Laurence, for inviting us to come and talk about what we've been doing with that project and Google Distributed Cloud. And yeah, if you or if anyone in the audience has any questions.
Yeah, no, I can certainly see there's some questions lined up. Really great presentation, Chris. Thanks so much for that. You've got a great job, haven't you? It's really interesting. What I loved also was the photos of you with the team, with Jorge, with all the servers. It made a bit of a 3D feel to it. So not often you get a presentation with people with servers in the background. So it's a nice break. Let's dive straight into the questions for now. I can already see there's one almost in the chat here from John, I could see. Chris, so what are the key challenges of creating this kind of flexible deployment fabric, in your opinion?
So, I mean, you referred to the pictures with the servers. For me, it was a novelty. You know, a long experience with servers, but I've been like working with cloud technologies for over a decade now, and probably servers more than two. So while it was a novelty and it was fun, it takes a lot longer to procure servers, get them racked, get them patched. We blew a power supply at one point. We threw a disk at some point. All of that stuff that we take for granted in the cloud. That hardware fails transparently in the cloud. You know, you don't have to worry about it. Infrastructure as a service, platform as a service. You don't have to worry about data center ops and power. Other thing, I got some extra GPUs. I chucked a couple of extra GPUs into the server. Nothing worked. Not enough needed uprated power supplies, all of that hardware stuff that you just forget about. But Google is busy doing that in its data centers, and that's why we've got this distributed cloud where you can kind of run what we call software only, but we can actually just provision it on hardware that we've built and tested with the top of rack switch and the right level of redundancy. We've got a lot of software redundancy built into it. You get all the great stuff from cloud where we have like a multi-node control plane, and you can actually do VM and container failover on the cluster. So we bring all those learnings for high availability and distributed services to Google Distributed Cloud. But yeah, the challenges are you're suddenly responsible for more than just the software configuration. You're suddenly responsible, and then moving the kit around. Taking it to other countries. We took it to Amsterdam, of course. All that stuff that you forget about. But where there's a time and a place and there's a need, then it's still useful. I hope that answers your question, John.
He's not here, but I can positively say I think it's all good with that. Maybe we've got time for 2 or 3 more here, but we've got a few lined up here. Brittany is asking, what are some cost optimization strategies you could recommend for this deployment?
So, okay, let's think of the cost. So what we see with the broadcasters, how this is potentially cost optimized. Now, might be slightly controversial, but the journey to the cloud has been long, and we don't think all workloads have moved there. It's only 20-25% of workloads have moved to the cloud, and there's still potential for a lot more to go. However, there are use cases, 24/7, 365 linear channel operations, where if you know what your compute workload looks like, and you're going to run it 24/7, 365, and when you hear later about optimizing your cloud workloads, it's only run what you need to when you need to run it. But if you know you need to run it 24/7, sometimes it's not always arguably more cost effective to run it in the cloud. You can run it in your own facility, in your own data center on-prem, where you originate your channel. So the cost optimization, what we believe here is for your known fixed steady state workload, Google Distributed Cloud. For your burst workload, pop up 10 channels for the Olympics, pop up 20 channels for the World Cup, cloud, and then collapse it down again. That's the beauty of the cloud. Scale to 0. Just build it, use it, throw it away. Whereas if you're running a bunch of linear channels, typically you can forecast out 2-3 years. So in terms of your optimizing your budget, some workloads for steady state on-prem, bursting into the cloud. So it could be a slightly controversial because the trends have been away from that. It's like everything in the cloud. This is a little bit beyond everything in the cloud. I sometimes call it beyond cloud. It's Google Distributed Cloud. Hope that helps, Laurence.
That's great. Thanks, Chris. I can see Steve just asked the question, hot in now. In what situations is this deployment fabric actually not recommended?
when do we not recommend a Google distributed cloud deployment fabric? Well, if it's a dev, test, experimental workloads, put it in the cloud. Really only if you know, because as I mentioned, the overhead of having to run and operate and manage hardware, not least the capex. Don't do it if you don't have to. Right? If you can run it in the cloud, run it in the cloud. But only if you need certain low latency or survivability without internet connection. You might want to run it on GDC. Otherwise, the cloud is super easy. I could deploy what you've seen there and probably by the end of the day in the cloud. But to do it again on distributed cloud, it's not as quick. So it's right. Use it in the right place. Don't use it when you've got good access to good internet connection and like 50 and 100 milliseconds of latency isn't your kind of pain point.
Great stuff. That's super clear. Super clear. Thanks, Chris.